Well, dear students, here come combination of unidentical cells. So, which cells are called unidentical if they don't have equal EMF and equal resistance? Then they are identical. So here our purpose to correct them in series or parallel is to find out equivalent EMF. How to find equivalent EMF and current drawn to current given by the combination to external conductor. So here figure shows two cells connected in series. Terminal A, B and B and C. B common to both cell E1, E2. Is that clear? So now we know when current is drawn from cell. We know when current I is given by a cell of EMF E and internal resistance small r, then terminal voltage, the terminal potential difference V equal to E minus IR. Is that clear? So here VA minus VB is the potential difference across terminal. Terminal are supposed to be at this point. So it will be E1 minus IR1 and VB minus VC E2 minus IR2. I think there is no trouble in this writing. It is simple to understand. VA minus VB equal to E1 minus IR1. VB minus VC equal to E2 minus IR2. Adding these two equations together. Adding these equations together, we get VA minus VC equal to E1 plus E2 minus I into R1 plus R2. If we connect a single cell of EMF E and resistance for R, and the terminal voltage across that between point A and C connect किया, if equivalent EMF of combination VE and internal resistance R, then on drawing current I from the combination, then if capital I be the current hold same potential difference VA minus VC, then we can write here what? If VA minus VC equal to E minus IR. Comparing this equation with VA minus VC equal to E1 plus E2 minus I R1 plus R2. तो equivalent EMP equal to E1 plus E2 and equivalent resistance R1 plus R2, यानी कि इसकी जगह हम एक सिंगल सेल ऐसे भी होते हैं कि E1 प्लस E2 तो EMF होगा और R1 प्लस R2 इंटर डिस्टेंस होगा बिटवीन A and C. That is the aim. So if we connect here n cells in series, if we connect n cells unidentical cell in series, then if n cells are connected then E equal to E1 plus E2 plus E3 plus E4 plus so on up to जितने भी हम उन सब का EM हो जाएगा. But if any cell is connected with wrong polarity, if any cell is connected with wrong polarity, wrong means भाई ये सब जुड़ रहे और उसका निगेटिव दर जुड़ जाए लाइक दिस, तो ये wrong polarity होगा. If it is wrong polarity, then the EMF of that cell will be taken negative. And hence, but internal resistance R to R1, but equivalent resistance R equal to R1 plus R2, whether wrong or correct. So that way, if n cells are connected in series, we can find EMF total by adding the EMF of cell and resistance by adding them. Now we come in parallel combination. Parallel combination of unidentical cell. Parallel. भाई सो थोड़ा डिस्टर्बेंस होगा. Now see, first we try two cell only in parallel. Point A or B. B. I1 current given by this, I2 by this. As much current is given, the same enter the cell at other terminal. I1 here, I2 here. So this is the combination of n cells or two cells in parallel. We know in parallel potential difference is same. So VA minus VB is equal to V. I write V here. Terminal voltage E1 minus I1 R1 equal to E2 minus I2 R2. दोनों करो. Using this and this and using this and this, क्या मिलेगा? I1 equal to E1 upon R1 minus B upon R1. Take this side plus ये minus जाएगा and then divide by R. And I2 equal to similarly E2 upon R2 minus B upon R. But I1 plus I2 is equal to I. But I equal to I1 plus I2. So I here will be I1 plus I2. E1 upon R1 plus E2 upon R2 minus, you can take V common, 1 upon R1 plus 1 upon R2. What is our aim? What is this V? Terminal voltage VA minus VB. So we want to find out equivalent. So we find V here. Take this side, na? V into 1 upon R1 plus 1 upon R2 is equal to here R1 R2 LCM E1 R2 plus E2 R1 or minus I. Or B into here LCM R1 R2 plus R1 is equal to E1 R2 minus E plus E2 R1 upon R1 R2 minus I, and hence B is equal to, when we divide by this side, what you will get? You will get E1 R2 plus E2 R1 upon R1 plus R2 minus I into R1 R2 upon equivalent resistance in parallel होता है ऊपर. Or you can write it as how? How can you write it? If equivalent is E, if E be the equivalent EMF of combination, and R be the equivalent resistance of combination, equivalent internal resistance, equivalent internal resistance. Then V equal to, write here equation 1, V equal to E minus IR, comparing 1 and 2, comparing 1 and 2, E equal to E1 R2 plus E2 R1 upon R1 plus R2 minus, और R equal to R1 R2 upon R1 plus R2, 3 and 4. So when two cells of E1, E2 interface R1, R2 are parallel, then equivalent EMF, so E equal to E1 R2 plus E2 R1 upon R1 plus R2, and their equivalent resistance R1 R2 upon R1 plus R2. Parallel resistance तो simple है, because cell has two characteristics, EMF and internal resistance. Both should be considered. Okay, what is the equivalent? Now, if I divide equation 3 by 4, dividing equation 3 by 4, we get E upon R is equal to, क्या होगा? E1 R2 plus E2 R1 upon R1 R2, और this can be as E upon R, E1 upon R1 plus E2 upon R2. इसको ना अलग अलग सकते ना, E1 R2 upon R1 R2 plus E2 R1 upon R1 R2. ये R2 cancel, ये R1 cancel, we get this. So this has been done only here. Purpose is there. If n cells are connected, so if n unidentical cells connected in parallel, then equivalent E upon R, E is the equivalent EM, R is the equivalent resistance, equal to E1 upon R1 plus E2 upon R2 plus E3 upon R3 plus so on up to plus En upon Rn. Where what is 1 upon R? 1 upon R1 plus 1 upon R2 up to plus 1 upon R. Dear friend, questions are asked on this combination, parallel C over unidentical. This topic is introduced here before 6 or 7 years. So, and question has been asked twice from this. Problem is that if we have got one paper only of 70 mark, 3 hours, so how to evaluate the student here? So they mix the topics together and they frame the questions only of 1 mark, which can involve 2 or 3 chapters. So only to get success, we have to learn the topics taught in the class very carefully, and they will be learned only if you solve problems. I got message, sir, please write lectures, sir. Actually, I give lecture, but numericals are given at the same point just to understand whether you have got it or not, and that make you learn easily. So, thank you, dear students.